Hello, my name is Robert Mugere, and today I would like to take you through a class on sensors. The first question is, what is a sensor? A sensor is an input device which provides an output signal. This output is in respect to a specific physical quantity. A sensor is also a device which converts signal from one energy domain to the electrical domain. For example, heat energy to electrical energy, sound energy to electrical energy. Here we have the process diagram for a typical sensor. Now, at the beginning, we have an input. An input can be any physical quantity which we want to measure. This is a force, pressure, strain, light, sound, etc. Now, this physical input causes a change within the sensor. This change within the sensor is then detected by the signal conditioning unit. The signal conditioning unit will convert this change into an electrical signal, which is then the output. The output is an electrical signal conveying the change in an input. Next, we will have a look at the classification of sensors. Sensors are classified according to different criteria. Now, the first criteria we're going to look at is active and passive sensors. An active sensor requires an external power signal in order for it to function. In the natural world, we have an example of an active sensor in a mammal known as the bat. The bat uses a technique known as echolocation to be able to navigate. Echolocation works like this. The bat produces sound. This sound is then bounced off obstacles. Once it is reflected back, the bat is able to pick up the sound waves and produce a mental map of the terrain. In this case, the bat acts as an active sensor because it produces sound waves which it uses to measure distance. In much the same way, active sensors produce their own signals for measurement, and that is why they require a power signal. On the other hand, passive sensors do not require any external power signal. In nature, a passive sensor is found in the human eye. The human eye does not produce light of its own. Instead, it absorbs the light generated from the environment, transmitted for processing in the brain where the image is formed. Passive sensors work in the same way. They do not generate signals, they simply act as receptors, which then transmit the signal for processing. Another type of classification is based on the means of detection, that is, electric, biological, chemical, radioactive. The next classification is based on the conversion phenomenon, that is, the process that changes the input to the output. The most common conversion phenomena are photoelectric, where we get light being converted into an electrical signal, thermoelectric, where we get heat being converted into an electrical signal, electromechanical, electrochemical, where we get chemicals chemical energy being converted into electric energy. We also have electromagnetic, where we get magnetic energy being converted into electric energy. And then we have thermo-optic, where we can have heat energy being converted into light energy, which can then be detected using a photoelectric sensor, which can detect light energy and convert it into electric energy. Next, we have contact sensors and non-contact sensors. A contact sensor is one which comes into contact, or one which touches the element being measured. What this means is that the energy to be measured, or the element to be measured, comes into direct contact or touch with the sensor. A non-contact sensor does not touch the element being measured. The final classification for sensors is analog and digital sensors. Analog sensors produce an analog output, that is, a continuous output signal. This can be in the form of a voltage, which is then measured. Digital sensors work with discrete or digital data. The data in the digital sensors, which is used for conversion and transmission, is digital in nature. An example of an analog sensor is a temperature sensor. This is a sensor which will be able to measure the change in the temperature continuously depending on the environment. For example, if you're boiling water, the temperature of the water is likely to change continuously. Digital sensors deal in data that is in 0 and 1 form. We are now going to look at the common types of sensors. Keep in mind that these sensors can fall under any of the multiple categories which we have looked at. The first sensor we're going to look at is the temperature sensor. As stated, it can be analog or digital in nature. A change in temperature can correspond to a change in a physical property like resistance or voltage in the sensor. That is for analog temperature sensors. In the analog temperature sensors, a change in the temperature corresponds to a physical change in a property of the sensor. One of those properties can be resistance or voltage. Digital temperature sensor is able to convert the temperature directly into a digital reading. Next, we have proximity sensors. A proximity sensor is a non-contact type of sensor that detects the presence of an object. A proximity sensor can use different techniques of sensing. For example, optical, sound, magnetic, capacitive. An example of the sound technique is the echolocation technique, which birds use, as described earlier. Sound wave is sent out. A sound wave is sent out, and when it hits a barrier, it produces a reflection. And when it is reflected back, then the receiver is able to pick up on the distance between the receiver and the barrier, the distance. The most basic form of an infrared sensor is the transmissive type infrared sensor. Now, it consists of an LED and a receiver. Now, the LED and the receiver, the emitter and the receiver, will be transmitting a signal between them. When an object interrupts this signal, the sensor is able to pick up on the change of the interruption of the signal. Another type of infrared sensor is the reflective type, like shown in the picture adjacent. Now, in the reflective type, the LED and the receiver are both adjacent to each other. Now, the transmitter will transmit infrared rays. When the rays meet with an object or an obstacle, they are reflected back and picked up by the receiver. Now, this is different from the transmissive type in that in the transmissive type, the emitter and the receiver are always in contact and detection is done when the signal is broken. But for the reflective type, the emitter or the transmitter will always be producing a signal. A reading is made when the signal is bounced back and received by the receiver. Now, the next example is the ultrasonic sensor. The ultrasonic sensor works using the echolocation method. It produces a sound, an ultrasonic sound, and this sound is then reflected back off the object to the receiver. Now, one advantage of an ultrasonic sensor is that due to the nature of sound, we can be able to determine distance. Sound through the Doppler shift property can also be used to determine the velocity. So this sensor can be used as a proximity sensor, it can be used as a distance sensor, and it also can be used to read the velocity of an object in motion. Now, in the light sensor, light is used to produce a change in the sensor. The most common example is a light dependent resistor, LDR. The LDR is a resistor which is a variable resistor which changes based on the light. The more light there is, the less resistance this resistor has, and vice versa. There are also two other types of light sensors. That is the photodiode. The photodiode changes the property of a diode based on light, and the phototransistor, which changes the properties of a transistor based on light. All of these are analog sensors which produce an analog continuous output. Next category or next example is smoke and gas sensors. These are sensors which can detect different gases based on different chemical reactions or properties of the gas. The next sensor is an alcohol sensor. An alcohol sensor is a type of chemical sensor which detects alcohol. The alcohol in the air blown into the sensor produces a physical change in a quantity within the sensor. It is commonly used within breathalyzer devices to determine how drunk a person is. One of the most common sensors in today's world is the touch sensor. The touch sensor is able to detect the human finger or a stylus. The most common technologies used to make touch sensors are resistive or capacitive. In the recent years, capacitive touch sensors are more common because of the accuracy and better signal to noise ratio, meaning they suffer from less interference. The next sensor is a color sensor. A color sensor is simply a sensor which is able to detect the colors. Every color has its own unique wavelength. This sensor is thus able to detect the unique wavelength of every color. The next sensor is a humidity sensor. The humidity sensor measures a value known as the relative humidity. Relative humidity is the ratio of water content in the air to the maximum potential of the air to hold water. Now, to explain relative humidity, if you take the air within a room and you measure the amount of moisture or water in that air, then you measure the maximum amount of water which this air contained within the room can hold. That ratio will give you relative humidity. Temperature is a function of relative humidity. So, most or all humidity sensors can also measure temperature. Humidity sensors are classified into capacitive, resistive, and thermoconductive type, depending on the type of technology used. The final example of sensors that we're going to look at today is the tilt sensors. These are used to detect inclination or orientation. Previously, such sensors are made out of mercury or made using mercury. This is where mercury was used to complete a circuit since it is a liquid in room temperature with solid properties. Hence, it was able to conduct electricity. These sensors were commonly known as mercury switches because once you tilted them, the mercury would flow towards one point where it would complete a circuit. However, modern tilt sensors contain a roller ball. These are not the only sensors available in the market. These are just examples of the most common sensors that you will find in use today. However, based on the different classifications of sensors, we have a ton of sensors out there for use in various industries. Thank you. We have come to an end to the basic introduction of sensors.